multiply rational expressions, I will use exactly the same procedure as I use for multiplying fractions. Namely, first I'll multiply the numerators, then I'll multiply the denominators, and finally, I'll factor and simplify. So let's see an example first where we have only monomial numerator and denominator. Let's suppose we want to multiply these two rational expressions. First, we'll multiply the numerators and the denominators to get a single rational expression. One thing I'd like you to note here, note these parentheses. Why are they there? The fraction bar in order of operations acts as a grouping symbol. Whenever we see a fraction bar, we should note that the numerator and denominator are grouped together. We must do any arithmetic we see in the numerator, any arithmetic we see in the denominator, before we do any other arithmetic. So whenever we've written the expression that shows that we've multiplied our numerators together, we must include parentheses. In this example, since the only operation in the numerator is multiplication, the only operation in the denominator is multiplication, these parentheses aren't serving any purpose, so we can drop them. We'll have 3 times 15 x squared y a squared b over 5 times 8 ab squared xy to the fourth. Notice, I haven't done the multiplication in the numerator and the denominator. I have written the coefficients together at the beginning just because that makes it easier to look at. Before I carry out any more multiplication, though, I'm going to cancel common factors. I see that 5 and 15 have a common factor, namely 5. A and a squared have a common factor, namely a. B squared and b have a common factor, namely b. X and x squared have a common factor. Y and y to the fourth have a common factor. Alright, so what do I see remaining here? In my numerator, I'll have 3 times 3 is 9. X to the first power, a to the first power. In my denominator, I'll have 1 times 8 is 8, b to the first power, y to the third power. So this expression is the product of these two. I'm going to give you one of these to try with only monomials, and then we'll see an example that involves polynomials. Multiply these two rational expressions. Pause the video and try this now. Alright, our first step, again, will be to multiply the numerators and multiply the denominators. Next, we drop the parentheses and write the coefficients out front where they're easier to spot. Then let's see, 35 and 7 have a common factor of 7. 8 and 12 have a common factor of 4. W to the fourth and w squared have a common factor of w squared. X cubed and x have a common factor of x. U squared and u to the fifth have a common factor of u squared. V and v cubed have a common factor of v. Y to the fourth doesn't have anything in common with anybody. So looking at what's left, in the numerator I have 1 times 3 is 3, and the only remaining variable is y to the fourth. In the denominator I have 5 times 2 is 10, w squared, x squared, u cubed, v squared. And this is my answer. Alright, what about when these involve polynomials? Let's say, for example, we wanted to multiply these two rational expressions. Well, again, our first step would be to multiply the numerators, multiply the denominators. Now it's at this point where we could make a very poor technical decision. On no account do we want to multiply these out. Why don't we want to multiply these out? Well, we're just about to factor them. We should take advantage of the fact that these are already mostly factored, so we don't have to work any harder than we really need to. Our numerator is currently factored as 3x squared minus 9x times x cubed minus 8. I see that these two terms have a common factor, namely 3x, so I can factor that out. And this binomial, I see that it's a difference of cubes, so it factors as x minus 2 times x squared plus 2x plus 4. And now this is always prime. The rest of these are clearly prime. I'm done factoring my numerator. My denominator is currently factored as x squared minus 3x plus 2 times x squared minus 9. This trinomial, we split up the middle term using two numbers whose sum is negative 3 and whose product is positive 2. And then we see that our factors are x minus 1 and x minus 2. This binomial is a difference of squares. It factors as x minus 3 times x plus 3. All right, then what does our original expression become? Well, our numerator is 3x, x minus 3, x minus 2, x squared plus 2x plus 4. Our denominator is x minus 1, x minus 2, x minus 3, x plus 3. Now we see we have common factors in x minus 3 and in x minus 2. And so finally, our answer is 3x times x squared plus 2x plus 4 over x minus 1 times x plus 3. Should we multiply this out at this point? Only if we need to. Why would we need to? At the moment, pretty much the only reason we ever need to multiply anything out is because we're about to do some sort of addition or subtraction. Since we haven't talked about any sort of addition or subtraction yet, let's stay with factored form. All right, I'm going to give you one of these to try. Multiply these two rational expressions. Pause the video and try this now. All right, our first step is to multiply the numerators and multiply the denominators. Our next step is to factor each. Our numerator is currently factored as 3x minus 9 times x cubed minus 4x. This first factor, I can factor out a common 3. The second factor, I can factor out a common x. I think I'll write these monomial factors at the beginning. I can't factor x minus 3 any further. But x squared minus 4 is a difference of squares. I think that's fully factored now. How about the denominator? Currently factored as x squared minus 2x times 3x squared minus 27. This first factor I can factor out a common x. The second factor I can factor out a common 3. Now again I'll write my common monomial factors at the beginning. X minus 2 I can't factor anymore. X squared minus 9 is a difference of squares. I can factor it as x minus 3 times x plus 3. All right. What does my original rational expression become then? Its numerator is 3x times x minus 3 times x minus 2 times x plus 2. Its denominator is 3x times x minus 2 times x minus 3 times x plus 3. What common factors do I see? Well, I see a 3 and an x. I see an x minus 3 and I see an x minus 2. Huh. All that's left then is x plus 2 over x plus 3, which is clearly simplified as much as possible and is my answer.